Hey there, in this video we are going to encounter some types of problems where we are given a linear function and 4 statements about it, and we have to pick which statement is correct. So we will look at 2 different methods. We will look at using a coordinate plane or a graph, and we will look at how we think about it without that graph. So again, just depending on how you think and how your brain works, one might be a preference for you over the other option. One thing I do want to point out before we get into either method, when you don't have a graph given to you, remember that you can create a coordinate plane yourself by drawing a vertical and a horizontal line that intersect. And then you can draw a little hash mark. So for example, if I know that I need a graph, like let's say 6, 4, that point, 6, 4, then I would go 1, 2, 3, 4, 5, 6 over, and then I'd go 4 up. And you could even label them so you don't forget later what they are. But 6, 4, that would be right here. Or if I know that I need to do -2, 3, then I would go this way 2, left 2, and then up 3, and I'd put a point right there. So that's just a reminder of how you can do that even when you are not given graph paper. I am going to have a grid already printed on my screen, but I wanted to just remind you of how you can do that if you don't already have that. So let's take a look. Here's our problem. We are considering the following formula: b plus 12 equals -6a. Which of the following statements is true for this formula? So we see in our answer choices that they are all formatted a similar way. They are formatted if a is something, greater than, less than, -6, -2, 2. We see different numbers and different descriptions, greater than or less than, but we see that they all start if a is something. Then in return, B is something else. So B is changing or dependent on A. So the first thing that I want to notice in these answer choices is that we have a cause variable and an effect variable. So a cause variable is essentially in that answer choice what part we are changing, or we are looking at if A is this or if A is that. This is what's happening to B. So the cause variable is A, and the effect variable, in other words, the variable that's changing based on the cause variable, is going to be B. Now, that's important to note because typically we have an X and a Y axis. So typically the horizontal axis is our X axis, and typically the vertical is our Y axis. But in this case, we don't have an X and a Y like we see in a typical linear equation. So I want to point out the cause and effect because we usually like to graph the cause variable as the horizontal axis and the effect variable as the vertical axis. So I'm going to label A as the horizontal axis and B as the vertical. Technically, you could do it either way, but I would suggest always doing that cause one as the X axis or the horizontal axis and the effect as the vertical. So next thing that I would suggest that you do, just like we've done in other linear equations where we did have X and Y, we're going to plug in 0 for what would be X and what would be Y. Now, I say what would be because obviously we don't have an X and a Y here, but that's like saying plugging in 0 for A and for B. So let's go ahead and do that in this given equation. B plus 12 equals -6a. So if we plug in 0 for A, we have B plus 12 equals -6 times 0. So B plus 12 equals 0. Subtract 12 from both sides, and we get B equals -12. So our ordered pair here, X comma Y, which would be A comma B in this case, based on how I graphed my axes, would be 0 comma -12. Let's do the same thing with B equals 0. So that's going to be 0 plus 12 equals -6a. So that's 12 equals -6a. Divide both sides by -6. And that's going to come out to be A equals -2. So in this case, our A goes first, which is -2, and our B goes second, which is 0. So we can go ahead and plot those 2 points accordingly. So -2, 0 is going to be -2 along the a-axis and then 0 up or down. So that's 1 point. And 0, -12 will be 0 left or right from the origin, but we go down 12 and put a point. And remember, if you're not given a graph, then we just draw the horizontal and vertical axis or axes, and we go ahead and label your points or plot your points using those hash marks and then a point where it's necessary. So I'm going to go ahead and connect those points now. So when I connect those points, I see that I have the intercept or intercepts in this case graphed. And so that's going to help me answer this question because I want to point out in a line the x-intercept, which in our case is the a-intercept along the cause variable axis, which is typically our horizontal if you use that same method I suggested. That is going to be the point where our line always changes either from positive y values or positive, in this case, positive b values to negative b values. So it's essentially above the a-axis are the positive and below are the negative. And I point this out because you'll notice that our options, our answer choices, yes, A is the part that we're looking at changing, but what we're looking to see in the graph to help us figure out which answer is correct is what is happening to the B values. Where are they positive? Where are they negative based on the A values? So let's read through our options. But before we do that, I do want to point out that -2, A equals -2, is the point where it changes from positive to negative. So that's that turning point or that changing point from the positive down to the negative. And again, that's at A equals -2 is where it goes from positive to negative. So option A, if A is greater than -6, then B is positive. So here's -6 on the a-axis. If A is greater than that, we have positive and we have negative. So if A is to the right of that, meaning any part of the line to the right of -6, we have positive and we have negative in terms of the B value. Okay, we have parts of the line above the a-axis and parts below. So that tells us that option A is partially correct, but it is not 100% correct. So we cross that out, we eliminate that. Let's go on to option B. If A is less than -2, so now we're looking at -2, which is this x-intercept or a-intercept along that horizontal line, that is the point where it changes from positive B values before that or lower than -2. To the left of -2, we have positive B values, whereas to the right of -2, as we're going right, it's going down, which is the negative values on that B axis. So if A is less than -2, so less than -2 would be this direction. So if I'm looking that direction, if I'm looking to the left, anything to the left of -2, notice that the line is going up and it will continue to go up forever. So those are all positive B values. So this is a true statement. Option B is true. If A is less than -2, if it's less than that turning point, meaning where it goes to the left of that -2, it's going up towards the positive B values. So that means B is correct, but let's make sure that we didn't miss anything. So we'll just double check C and D. So if A is less than 2, so if we look at 2 over here, that is not the turning point. To the left of 2, we have positive and we have negative B values. We have the line above and below the a-axis. So this is going to be one of those answer choices that's partially correct. So we can cross C out. And then D, if A is greater than -6, looking again at -6, again, that is not the turning point. So we're going to have a mixture of positive and negative values. So again, that's another partially correct answer. So B is correct because it's referring to that turning point and it's an absolute 100% correct answer. So let's take a look at a second method where you maybe don't need a graph. So thinking through the same thing, we have the same problem, the same mindset in terms of cause and effect can be helpful. So our cause variable is still A. That's the if part. If A is this, if A is this, if A is this. That is the cause variable. And then the effect variable, which is the variable that's, again, adapting or adjusting or changing based on the cause variable, is going to be b. So that is the same concept as the other method. So in this method, what we're going to do is we're going to find that turning point that we found in the graph, which is going to be essentially your x-intercept. So if you think about a graph, we're not going to graph this, but if you think about a graph like the one that we just looked at, that x value where it crosses the x-intercept or the x-axis is called your x-intercept. That point is what we want to find. That is our turning point where we go from positive to negative. Or even if the line had gone the other way, we go from negative to positive at that turning point. So we want to find that cause variable axis intercept. Lots of words there, but basically we want to find the point where the line crosses that horizontal axis, assuming that you use the cause variable as the horizontal axis. So we want to find our A-intercept. So we're essentially doing the same thing that we just did, but we're not going to find both intercepts and graph it and look at it visually. Now that you see visually what we're looking for, you may not need to do the graph. So we find the A-intercept. We always find that intercept by by plugging in 0 for the other letter. So if we're finding the A-intercept, then we're going to plug in 0 for the other letter, which would be B. So we do 0 plus 12 equals negative 6A. 12 equals negative 6A. We then solve by dividing both sides by negative 6. And that gives us A equals negative 2. And if A equals negative 2, that tells us the turning point. So again, while we are not necessarily graphing this exactly, we know that negative 2 is the point where it either goes from positive to negative or it goes from negative to positive. So that is the turning point or the changing point. So looking through these options, the only one that talks about if A is less than negative 2 is going to be that choice B, that option B. And you can check that just to make sure that it is 100% correct. We can check that to say if A is less than negative 2, then B is positive. We'll plug in a number less than negative 2 because we know negative 2 is that turning point. We know that to the left of it, it's either going to be positive or it's going to be negative. And this option right here is saying that it needs to be positive. So if I plug in a number to the left of negative 2, let's say negative 3, we can do B plus 12 equals negative 6 times negative 3. B plus 12 equals 18. Subtract 12 from both sides. B equals 6. And so that tells us that is a positive number. And if you really wanted to, you could also plug in negative 1 and you would see that that would come out to be negative 6, which is a negative number. So that's what tells us that option B is the correct answer, because if A is less than negative 2, then B is positive. We know that because negative 2 is our turning point, and we checked to make sure that when we plugged in negative 3, a smaller number, it did come out to be positive, okay? And this does work. Finding that turning point does work in terms of any linear function, because a linear function is not going to be able to cross the x-axis and then go back up and come back down. So when it crosses the x-axis, it goes into the negatives or goes into the positives, depending on the direction, and it stays in that spot, stays in that region. So we know B is our answer for this one. Some people prefer the graph and they're more visual. Some people prefer without the graph. So it's really just up to you and what you're more comfortable with. I do want to point out in terms of plugging in points, some people might think, oh, I just pick, for example, in option A, if A is greater than negative 6, I just plug in a number, and if it's positive, then that is correct. Keep in mind that these answers, these choices could be partially correct. So you can't necessarily just plug in and say, oh, it worked for that one number, so that automatically works. But if you are somebody that doesn't want to use either of these methods and you want to try a third method, technically you could plug in points to disprove a statement. So if I could find a point that disproves A, C, and D, I could cross those off using that disproving thought, and that would work as an option as well. So that kind of gives you 3 different methods. in terms of how you could solve this problem given these answer choices. So use whichever method makes most sense to you. So in a quick summary, we see just the things we talked about. Determine which variable is cause and which one is effect. Remember, when you are labeling your axes, if you're going that route, then our cause variable, I would suggest you put on the horizontal and effect on the vertical. While you can flip-flop those, that's what I would suggest you do. Eliminate answer choices when possible. So if something's not 100% correct, or if you disprove a choice, then eliminate it. Again, it has to be 100% correct to be 100% correct. It can't be partially correct. Sometimes they put partially correct ones on there to throw you off. Don't let that throw you off. And then sometimes we don't need a graph to get the answer. You could plug in values to disprove answers, or you could use the x-intercept or the cause variable intercept, the horizontal axis intercept, to find that turning point. And that can help you in those problems.